Okay, so we are continuing on with equations of parabolas, all the properties that we need to know. First one is we're going to go through and list all the properties. So quadratic function is given there. It says state the direction of opening. So some of these maybe we'll use our calculator to check, but a lot of them we should be able to do without. So remember, you look at the leading coefficient. If it is positive, it opens up. If it's negative, it opens down. So this one's negative, so it opens down because the A value is less than 0. Vertical stretch is the absolute value of that A value. It's always positive, so it's a half. So it's actually going to be wider than the original. And that was the next step. The coordinates of the vertex, remember it's the opposite sign of the constant. It's whatever x value makes that bracket 0. And the constant term outside of the squared is the y value. So that's found from the horizontal translation and the vertical translation. Equation of the axis of symmetry always is x equal, it's a vertical line for these parabolas, and it goes through the x value at the vertex. And then for the range, it's always y. If it opens down in this case, it's less than or equal to the y value at the vertex. Okay, the max or min y value and the value of x when it occurs, well, that's at the vertex. So in this case, it's 8. Is it a max or min? Well, if it opens down, it's a maximum of 8 when x is negative 3. Right? It all comes from the vertex there. And then the x-intercepts, this one, let's try to do it algebraically. So x-intercepts are when y is 0. So 0 equals negative 1/2 x plus 3 squared plus 8. So bring that over to be positive. Multiply both sides by 2. And square root. 16 is 4, positive or negative. And then x will equal negative 3 plus or minus 4. So what does that end up being? That could be negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Y-intercept, oops, that's just when x is 0. So that's going to be y equals negative 1/2, 0 plus 3 squared plus 8. So that's going to be negative 9 over 2 plus 8. 16 minus 9 is 7 over 2. Okay. Now, let's graph it. See what it looks like. So go to y equals, clear off, enter negative 1/2. You can use your fraction key, but why bother? It's faster. Just use divide. Bracket x plus 3, close bracket, squared, plus 8. And use a standard screen, because we know our vertex is negative 3, 8, so it's within that. Okay, check. We think our y-intercept is 7 over 2. Sometimes when you press trace right away, it goes to your y-intercept. 3.5 is the same, so that's good. Let's find our vertex. So second trace, which is calc, and we're doing a maximum. And then cursor to the left of where you think it is. Enter. To the right of where you think it is. Enter, enter. Negative 3, 8. That's good. So if you've checked the vertex and the y-intercept, you're good to go. Or you can check the x-intercepts. You don't have to do all of them. So we think, if you're in trace mode and you think one of the x-intercepts is 1, just go trace 1. And make sure that the y value is 0, because that's the x-intercept has a y value of 0. And then you're in trace, you can try negative 7, and it's 0. So from all values, we've got all of those correct. Okay? Okay, so let's write the equation of a quadratic function with no x-intercept. So think about what that looks like. No x-intercept. So that might be something like, want to do that. Something like this. Okay. Now this is a very rough sketch. Okay. But what do we know? Oh, what do we know here? Right? We talked about this the other day. So here, if it's opening up, okay, so that means A is greater than 0 and our Q is greater than 0. So an equation would be, I don't know, 3x squared plus 1. You can, now here, that's not the equation of this. This is moved over to the left. So you can translate this, but this has to be greater than 0, and this has to be greater than 0. Okay. One x-intercept. Just do this. Okay, one x-intercept is when it just touches. Okay. So it doesn't matter. So A could be anything, but this means Q has to be equal to 0. So this could be y equals 4 x minus 3 squared, y equals negative x plus 1 squared, etc. There's nothing out here. Okay. 2x intercepts. How about that? Okay, so what do we have here? So our A is greater than 0, but then our Q is less than 0. If we had something like this, then our A is less than 0, but our Q is greater than 0. So you could have 3x squared minus 2. You could have negative 2x squared plus 5. You can translate them. Okay, so, but those conditions have to be met. Okay. All right, next one here. Graph of y equals x squared was transformed to the graph given. Point negative 3, 9 lies on the graph of y equals x squared. Determine its image point after the transformations. So we've done something similar in the last note sheet. So this, we want to go through what's happened. So we have a vertical stretch by 3, reflection in the x-axis, horizontal translation 5 left, vertical translation 2 down. Okay, so negative 3, 9, vertical stretch by 3 changes the y value to 27. Reflecting the x-axis changes it to negative 27. 5 left, well, negative 3 minus 5 is negative 8. And 2 down would be negative 8, negative 29. Okay, so that is your transformed function. You can always check it, make sure that it works in your left side and your right side. So negative 29, and then negative 3 times negative 8 plus 5 squared minus 2. It's negative 29. Okay. Writing equations in vertex form. So determine the equation of the parabola with vertex 3, negative 5 passing through a point. So we can come up with most of our equation. We just don't know what A is. Because the vertex, remember, opposite sign. So if it's 3, then it's x minus 3. Then your negative 5 is outside the bracket, so minus 5. So we've got most of it. Now, this point tells us that when x is 1, y has to be negative 13. So now we can substitute those values in. Okay, and then simplify. So when I bring the negative 5 over, it's going to be negative 8. That's going to be 4a. So a equals negative 2. And then just rewrite it. And then you can check on your calculator. Clear off that. So you think it's negative 2 bracket x minus 3 squared minus 5 okay. Let's test the vertex, so trace negative 3. You can do a max. Okay, so I did something, oh, sorry, vertex is positive 3. That's no problem. So 3, enter, I get negative 5. Good to go, it's at the maximum. Then you can test your point 1, x equals 1, y equals negative 13. Okay, you can't see it on there. It's okay, it won't show you if the y value is into your screen, but if the x isn't, then it will give you an error. Okay, then this one, we have to come up with some of the information. So, find the vertex, that's 2, negative 8. Hard to know what the x-intercepts are. Looks like a y-intercept of 4. Okay, although that's a little bit hard to see as well. I would actually use this point because that looks good. So 3, negative 5. So I'm going to do this 2 ways because one way, so first let's get it without a. So put your vertex in. Remember when we graph them, if we go 1 over and then up from there will tell us our a value. So that's 3f. So really, this is 3, x minus 2 squared minus 8. Okay? You don't need to show work. If you do want to show work, then I would substitute negative 5 in for y when x is 3. So I'm going to show this in red. So you're substituting 3, negative 5. And then that's going to be 3, you don't know what a is. That's the whole point. We're doing it this way. Sorry. A here. So then that's a times 1 squared minus 8. Bring the 8 over. That's 3 equals a. And that's what we have. Okay. Let's see. Was that y-intercept 4? So if I put 0 in for x, I get negative 2 squared is 4 times 3 is 12 minus 8 is 4. So it is exactly. It's just a little bit hard to tell when your grids are small. Okay, next one, determine the equation of the parabola with range y greater than or equal to negative 6 and x-intercepts of negative 5 and 3. I would actually do a little sketch. So y greater than or negative 6. So let's say this. So let's say negative 6 is here. And x-intercepts of negative 5 and positive 3. Okay. And it's y greater than, so it's going up from there. So that means it has to open up. You know then, for your vertex, the x value, the y value has to be negative 6, but the x value has to be halfway in between negative 5 and 3. So really, calculate your axis of symmetry first. So axis of symmetry is x equals negative 5 plus 3 over 2, the average, which is negative 1. So therefore, the vertex is negative 1, negative 6. So it's going to be here, going like this. Okay. All right, so then we've got y equals a x plus 1 squared minus 6. And you need to figure out what a is. So use one of the points. Let's use 3, 0. So y is 0 when x is 3. So we substituted x values in. Bring the 6 over, and 4 squared is 16. So a is going to be 6 over 16, which reduces to what? 2 goes in at 3/8. So then your equation is y equals 3/8 x plus 1 squared minus 6. You can test, maybe put in -5, right? Another point, so -5 plus 1 is -4 squared is 16. Divided by 2 is 2, times 3 is 6, minus 6 is 0. So, yeah. That's your equation. And again, you can graph it and test some of the points as well. Right. Okay, number 7. The equation of the axis of symmetry of a graph is x equals -1. Passes through those points, determine the equation of the function. Okay, so, let's graph an axis of symmetry. Like that. Graph passes through the point 0, 3, and -3, 9. Okay. And, right, so in this case, we could have it opening up or perhaps opening, well, no, sorry, we can't open down because this unit is, so this is a y intercept. It's got to be the same on the other side. This point has to be the same on the other side as well. So you can tell it's got to be parabola opening up. We don't know what the y value is, okay? But we know that the vertex has an x value of -1. We're not sure about the y value. So, may have to do system of equations, but let's think about what happens here. From the vertex, 1 unit over is however many units up. We're not sure. Okay, this point here would be +1, 9. This was at -1 here. And this would be at, this point would be -2, 3. And we know this is -3, 9. So from 1 for 2 units over, okay, we're up here. This was at 3. So we've gone 6 units. Normally on your base graph, from here to here, that's a y value of 1, a y value of 4. We've gone 3 units. So this is twice as much. So that to me tells me that my stretch factor is 2. This is going to be x plus 1 squared. And then if my stretch factor is 2, then 3 would have to be 2 units above the vertex. Okay, so that would be a +2. Plus vertex would be at 1. Okay, so let's test it out with some points. So let's try -3, 9. So we'll put left side, right side. So we'll put 9 on the left. 2 times -3 plus 1 squared plus 1. 2 times 4 plus 1 equals 9. Okay. So I determined that, but I determined it using the graph, a sketch. It doesn't say algebraically determined, so as long as you show some work there, that's okay. And then we avoided using a system. Okay, and then the last question, a cable that supports a suspension bridge is parabolic. The horizontal distance between the ends of the cable is 140. Midpoint is 14 meters below each end of the cable. Determine the equation of the model. So this is very common, this type of question. Figuring out the shape of the bridge, the equation that forms it. So we're going to say the vertex is at 0, 0. So that means when I graph, I'm going to have to, oops, not that. I'm going to have to, okay. So there's a y-axis. there's an x-axis. Okay? So that means our vertex is at 0, 0. So now we're going to have y equals a x squared, just that, because it's at 0, 0. Another point on our graph, another point on our graph here is 14 meters up and half of 140. So that would be 70 and 14. Okay, so 70 and 14. So 14 goes in for y, a times 70 squared. So that's 4,900 a. So a is 14 over 4,900. 100 over 14. 350. So 1 over 350. Okay, so then our equation is y equals 1 over 350 x squared. Now, you're not going to have to do that every time because this is the exact same cable. It's just that the vertex is in a different place. So the vertex is on the x-axis at the left end of the cable. Oh, sorry. The vertex is on the x-axis and the left end of the cable is on the y-axis. So now we're going to show this. Vertex is on the x-axis, so just move that a bit, and the left end is on the y. Okay. So now, this vertex is now got an x value of 70, y value of 0, and this is 14 there. So same shape, nothing's changed. So that means the a value is the same. But now our vertex has been translated. So it's x minus 70 squared. And it's on the x-axis, so there is no q value. And the left end is at 0, 0, so here, that. So now, this is 0, 0. The vertex now is 70 for x, halfway, and then 14 meters down, so negative 14. So again, same stretch factor, but now it's been translated both directions. Okay, so exact same stretch factor, different locations for the vertex, exactly the same cable. It just depends where you put your origin. Okay, that's it.